Okay, so this question is on plane geometry. Okay, so before you try proving, do make sure you read the question first. Okay, so the first part will be there's a circle passing through ABC. They already draw the circle for you. And we have a tangent. So whenever there's a tangent, do be sensitive. Do be sensitive to the tangent chord. Okay, and then D and E lies on the two respective lines. The important thing will be this cyclic quadrilateral. So the cyclic quadrilateral, can you see these are the 4 points? So what does that mean that this is a cyclic quadrilateral? That means actually this 4 point will form another circle. Okay, so I'm going to try to draw through, even though the circle doesn't look very nice, but it's actually supposed to be a circle. Okay, so there is a circle here. The circle that creates the cyclic quadrilateral. So even though it doesn't look like, it's still applicable. It's not exactly drawn to scale. So our aim is to prove that DE is parallel to, so my aim is to prove that DE is parallel to FT. Okay, so if you need to prove parallel, you will need to try to come up with some alternate angle, interior angle, or corresponding angle. So these are the properties that can help you to prove parallel. So that means you need some angle. So in this case, you need to assign some algebra. So the algebra that I'm going to assign, okay, so the aim is the two yellow line to be parallel. So before you prove parallel, they are not parallel yet. So what I'm going to do is I'm going to assign x here. So I'm going to assign x here. And this is also an x because of tangent chord theorem. So you need to try and error first. So I'm going to assign this as x. I'm going to play around first to see whether it works out or not. So don't be concerned about writing statement first. So if this is a tangent chord that you can see, will I be able to get some alternate angle or something or not? So let's see. The next one will be the cyclic quadrilateral. So there will be a cyclic quadrilateral. And because of the cyclic quadrilateral, this angle here, which is exactly opposite, will be 180 minus x. Can see? So I apply a tangent chord. The red color is a tangent chord. Then the blue color is a cyclic chord. Angle opposite the cyclic chord. And then after that, if I use angle on a line, I will get this part as x. If I use angles on a straight line, I will be able to get x. And can you see? This is like an alternate angle. So this will be like the alternate angle. So in statement wise, we will call it by the converse of alternate angle. Okay, so if you look at the plan is to let the x be this one. So I started off with EAT. I started off with this as x. After that, the x here is due to tangent chord. So you got to explain. You got to explain why this is an x. So you just have to explain that that's a tangent chord theorem. And then how do you account for the blue one? How do you account for the blue one? DEC is actually 180 minus x because it's angles in the opposite segment. Each algebra should be accounted for by a certain property. And then eventually I gotten the x here, DEA, I gotten the x from angles on a straight line. So it's a very simple statement, but every algebra should be accounted for by some property. So eventually you will need to explain that since DEA is equal to EAT equal to x. So both of them are x. So you got to explain by the converse of alternate angle. Then DE is parallel to FT. So that is the algebra approach. If you are using algebra approach for angles, you make sure that every algebra is accounted for by some property. So even though it's 5 marks, actually the working is not very tedious. It's not as tedious as like differentiation or integration.